Hey guys, this is section 1 and 2 about chapter 4. First thing we're going to talk about is observing the solar system. And so in ancient times we had Greeks noticing the pattern of stars and called them constellations. You may have heard of that. And we had a geocentric system, which meant they thought the Earth was in the middle of everything and that the planet and stars revolved around it. And then his model was, Ptolemy was the first developed geocentric model, and his model was the universe was accepted for a really long time, for 1500 years. Then we had Copernicus, and he said, the first one to come out and say that he thought the planets and how they all moved around the sun instead of around the Earth. That's called a heliocentric system. And Galileo, when he developed a telescope, supported that theory. So he was really excited about it, but then it was very unpopular, and he was found guilty of heresy and was put under house arrest by the Pope at the time. 20 years, for more than 20 years in the late 1500s, Brahe observed and recorded positions of the planets, and Kepler used the data to develop 3 laws, and this is how planets move. So the first law, it says the orbit of each is an ellipse, which is not a perfect circle, and each planet moves faster when it's closer to the sun and slower when it's further away. Kind of slingshots around the sun, if you can think of it that way. And the third law says planets closer to the sun go faster around the sun than planets further away from the sun. So that should all make sense, hopefully, to you. The planets vary greatly in size and appearance, and they differ in mass, composition, axis tilt, and distance from the sun. So in space, we use, in our solar system, we use an astronomical unit to measure distances. When we go outside of our solar system, we'll use a light year, but within, we will use an AU, an astronomical unit, which is the Earth's average distance from the sun, about 150 million kilometers. So here's the sun, and these would be the planets. If you were comparing. And Pluto is considered a dwarf planet, actually, so it's not really considered a true planet anymore. Let's talk about the sun. It's a huge ball of ionized gas or plasma, and it accounts for 99.8% of the total mass of the entire solar system. It's made up mostly of hydrogen and some helium, and they have small amounts of other elements. But because of its mass, it's so big and its gravity so strong, it can hold all the planets and all of their moons in orbit. So it is a star. It's not a planet or moon, but it's a star. It gets its energy from nuclear fusion, which they start off with hydrogen and helium here. Fusion occurs. This is the process by which we have nuclear fusion. And it has layers, just like the Earth has layers. So on the interior, we have the core, radiation zone, and convection zone. And on the exterior, we have the chromosphere, which is a thin layer, the photosphere, which is the visible surface. We have sunspots, solar flares, prominences here, and the corona, which is what extends out into space. So the core is where the fusion is occurring, and the temperatures and pressures are extremely high there. Radiation zone is the interior where the energy is transferred from the core to the surface, or the convection zone, with tightly packed gases, and the outermost layer of the interior is where hot gases rise to the surface and cooler gases sink. We have a convection zone somewhat similar to that on Earth. On the outside, we have the photosphere, which is the inner layer of the sun's atmosphere. It's visible to the surface of the sun. It's what you see. And the chromosphere is the thin reddish layer of the sun's atmosphere just outside of the photosphere. The corona, the outermost layer of the sun's atmosphere, is which appears as a white halo around the sun, and it means the crown. And we can see that corona during a solar eclipse. Sunspots are areas of gas in the sun's surface that are cooler than the surrounding areas, and they move across the surface, showing that the sun does rotate like the Earth. Prominences are the huge loops of reddish gases that link sunspot regions to different sunspot regions. And if this were the picture of the sun, the Earth would be the size of that dot. Solar flares are eruptions which send hot gases out and millions of joules of energy streaming out about half of the speed of light. The corona extends out into space 1,000,000 kilometers until it thins into streams of electrically charged particles that are known as solar winds. And solar flares can cause great increases in number in the particles that reach the Earth. They can also damage our satellites and disrupt radios and TV and phone signals. But at the poles, those particles can kind of enter our atmosphere through this little tip here and the bottom here. And that's what causes the auroras. And that's it.